All right, we're now recording. All right, let me go back. I'm going to do a quick attendance for those that are physically here and for those that are online. That way I have a record of that. So we're doing attendance tracking. It is Tuesday, 21 February. And we're just doing the in-person portion. Miss Gillis is making it. That's good. And we'll get the attendance done. So Jaden is not here. Clarissa made it. Welcome. Jalissa made it. Maria can't make it today, apparently. Austin could. Faith is with us online. Cheyenne is not here yet. Kiara is not here, and Jacob is. So that's who's with us in class today. For those of you all who are not here now, hopefully you're watching this online. Getting things good to go. I'm not bringing a pen. Oh my gosh, I'm like penless today. Go to break out a pen and I don't have one. Switch jackets and I forgot to move pens. We have a solution for that. Not a pretty solution, huh? All right. Hopefully this works. All right, let me stop. Before I jump in anymore, I asked a little bit earlier, but does anyone have any specific questions, any problems, any concerns from any of the sections in Chapter 5? We have a Chapter 5 test on Thursday. So between now and then, you should be able to finish up all your homework, be ready to take your test. Any questions from anyone? All right. Given that, I've covered most of the material. There's some things I probably glossed over, didn't get in detail. So what I'm going to do is I'm just going to go through the review homework myself. That way you all can see it. There's obviously previous semester videos as well that you can watch if you get bored with those. All the stuff in your books, you're familiar with what Pearson has available for you for a lot of different things. You can take the Chapter 5 test that the author created as well, and you can take that as many times as you want to practice for your test. I encourage you to do that at least once before you take my test. If my test is the first one you're taking, you're probably doing it wrong. All right, so let's go back here. Where we want to go is go to, I'm going to change cameras so that we can see here. And then we're going to pin this sucker up so we can see it. And I'm just going to pop into my labs. For those of you playing totally at home, this test on Thursday, it does not require a proctor, but your final exam on 8 May will. So if you're not physically taking it in the classroom with me, you'll need to get a proctor approved. If you've submitted those, I haven't reviewed them. I got to go through and do that here this week and next, see if anyone submitted them, and start lining that up. Ooh, Cheyenne made it. I've got time to fix this then. Let me just do that while we're thinking about it. So Cheyenne made it. And Jaden made it. Ooh, okay. All right, so Jaden is here less than 5 minutes, so that's not tardy. And Cheyenne is here, and Maria. Wow, we had a whole host of folks. Okay, so pretty much everybody has made it online by 8:04, so we're good. Kiara is usually working, so I don't expect to see her. That's a good deal. I'm glad to see everybody online. Hopefully this is working for you. All right, so we are back here going into my labs. Hopefully grades are posting right. Everything's good. And for those just joining, if you've sent questions to me, let me know, but nobody that was initially on had any questions. So my intent is to just jump right into the review homework for your test and just get through as much of this as I can here. If I don't get through all of this here, I'll probably do a session later on to finish this off. So we're going to convert from degrees to radians, radians to degrees. You need to know how both are. 29 pi over 18. Stop the share. So this one wants you to convert from radians to degrees. I know you all online didn't see the question, but I'm not going to worry about pulling that up yet. First thing to think about just in your own head, right? So 36 pi over 18 is 2 pi, which is 360 degrees, right? So this is less than 36. It's like 7 less. So, you know, it's going to be 270-ish. That's the kind of number I'm expecting, you know, 250, 280, 300, something like that. Now, the actual factor, right, is 180 degrees over pi, because 180 degrees is pi. 360 degrees is 2 pi, right? So our unit conversion factor is either pi over 180 degrees or 180 degrees over pi. We're converting from radians. If there's no unit here, then these are in radians. Radians are a ratio, right? S equals R theta. Theta in radians is S over R. That's an arc length, and that is a radius length. That's inches over inches. It's centimeters over centimeters. It does not have a dimensional unit on it. Okay, so just reminders of things from back in section 1. At this point, this is 10 degrees, pi goes to pi, and the answer is 290 degrees. You can do that right in your head. It's in the ballpark of what I would expect. 290 degrees, I'll buy that. So the exact answer is 290 degrees. Bing. I'm not guessing. I checked my answer with an estimate. So show your work, check your answers. Draw the angle in standard position. All right. Again, 11 pi over 6. Okay. So again, 12 pi over 6 is 2 pi. It's 360 degrees. So standard position, right? There's the first ray. I put my vertex at the origin. This is almost a full circle, but I'm pi over 6 or 30 degrees short, right? So this is my reference angle here is pi over 6, which is 30 degrees. And you should be able to eyeball about 30 degrees. You should be able to eyeball about 45 degrees. You should be able to eyeball about 60 degrees, right? So that would be 1, that's 2, that's square root of 3 if I was doing all the other work. This just wants the thing in standard position. That's all they want to see. This is a skill. You ought to be able to sketch these and draw a reasonably accurate sketch. And there it is, C. Boom. Okay. That angle is in quadrant 4. You need to know your quadrants, right? And they go, everything runs counterclockwise. So 1, 2, 3, and 4. All right. Check, and we move on. Find a positive angle less than 360 that's coterminal. So there's a lot of terminology. Coterminal means when you draw it in standard position, it creates the same angle. So they said negative 120 degrees. So that's 30 degrees more than 90. That's down here. Negative 120 degrees. And they want the answer in degrees, right? So that's, in other words, right, 360 degrees, which would be, if I go all the way around and then go back, that's 360 degrees minus 120 degrees, which is 280? No, 240. There we go. 240 degrees. 270 is straight down. I'm like 270. My arithmetic brain is not working. 240 degrees. It's 180 degrees plus 60 degrees. That certainly makes sense. That's it. That's my coterminal angle, right? It is coterminal. They have the same base ray running along the x-axis, and they have the same terminal ray that runs through the same set of points, this ray right here. These are coterminal. 120 degrees is not 240 degrees. They are not equal. They are coterminal. They have the same reference angle. They'll have the same trig values, hence the repetition piece. But that is not the same. They're 360 degrees or 2 pi out. So the right answer to this one is 240. The arithmetic's not hard, but understanding the terminology and the language, and very often we want answers. This said positive, so it's got to be greater than 0 and less than 360. Right? So that's what they want. They want theta in that range. And in our case, the answer is 240. And on we go. All right. Use the triangle to evaluate without knowing. Sine of 45 degrees. I don't need their triangle. I know mine. So sine of 45 degrees. I want an exact answer. Now, I could go to my formula sheet and get this, but I should not need to. An isosceles right triangle, 1, 1, square root of 2. Sine, so opposite over hypotenuse, right, is 1 over the square root of 2. And when I rationalize the denominator, that's square root of 2 over 2. That's it. Okay, you don't have to memorize it. Just draw a picture. That's sine of 45 degrees. There it is. 45 degrees, and you can even think of it in standard position if you want. It's in quadrant 1. Sine is positive there. They want an exact answer, simplify, use radicals, and rationalize the denominator. Now, does it tell you to rationalize the denominator? I don't know. I'm going to do it this way just to see what it does. Now, if it specifically says, I can't read all the words because of the crap on my screen, so I can't actually see whether it says to rationalize the denominator or not. It says it's correct, but I need to fix it, which is fine. If you put that on your test, if it says to rationalize the denominator, I'm still going to give you most of the credit, because when I'm working with trig, this is how I do it. If I put it in my calculator, this is how I do it. I don't do the extra work. I let the calculator do the work if I'm doing a decimal approximation. So just be aware, rationalizing the denominator is a skill. You need to know how to do it, but it's the least important skill we've got here. And Kiara made it. Nice. So we'll put it in as SQRT. Square root of 2 over 2 is what they're looking for. Yay. And on we go. All right. Sine squared plus cosine squared equals 1. This is the Pythagorean identity. So sine of theta is 4 over 7. It's acute. So theta is between 0 and 90 degrees. It's in quadrant 1. So I know where to draw it, and I can find all of the other trig ratios using the Pythagorean theorem. So I'm going to, good morning, Ms. Chiara. So I'm up here in quadrant 1. That says my angle is acute. So I'm going to draw it up here in quadrant 1. Sine, my opposite is 4, my hypotenuse is 7, right? So that's a little more than a half. Sine of a half is 30 degrees. So I'm going to draw something like that. That's 4, that's 7. Okay, now that's my sketch. That may not be to scale. If you actually drew this thing to scale, you could find and measure the angles, and you could do this graphically. But we're just trying to find the other trig ratios. Now, which trig ratios did they want us to find? They just want cosine. Okay, so sine is opposite over hypotenuse. They want adjacent over hypotenuse. So we're just going to use the Pythagorean theorem, right? There's different ways to do this. I'm just going to do it right off the triangle. You could also use the Pythagorean identity to find it, but I'm not going to. I'm just going to do it this way. 7 squared is equal to, if I call that A, that B, and that C, that's little c, that's little a. This guy is little b. That's b squared. I wanted to get a name. I could have just said x, but I like using the trig letters here. Plus 4 squared. So 49 is b squared plus 16. Subtract 16 from both sides. That's 33 3 is b squared. So this is the square root of 33 is b. It's a plus or minus, but it's a distance, so we're going to ignore the negative one. This distance is square root of 3. Where would the negatives be? If I knew the angle was, if I knew sine was negative, but if I knew the cosine was negative, or they could give me information about the angle that put me in another quadrant, that's when I might get some of these negative values for sine instead of some of the positive ones. So just depending on the context of the problem, it might make sense to have a negative solution. In this case, it does not. I'm in quadrant 1. All of my trig values are positive. So in this case, cosine of theta, ca, adjacent over hypotenuse, is square root of 33 over 7. That's it. That's the exact value. Now, there are ways to check that on your calculator, but I'm not going to do that because I'm just trying to get through. How would you check that on your calculator? Actually, I am going to show you how to check this quickly on your calculator. So that's what I say the cosine is, right? So sine theta equals 4/7. What is that angle approximately? Well, let me fire up the calculator. I'm going to just check this on my calculator. Share screen. So in order to check this on my calculator, I want to find an approximation for theta, right? So sine is 4/7. So if I go 4 over 7, boom, I'm going to do the sine inverse. I'm going to find the angle. So I'm going to go, lordy, second. What the hell was I thinking? Second sine inverse of that. Or I could type the 4/7, but I just already typed it. So boom, enter. This is going to give me the angle in radians. That's my angle, right? So theta is approximately 0.6082 radians. What's the cosine of that? Well, cosine of that. Boom. Right? So cosine of 0.6082 is approximately 0.8207. Now, that's using trig values, inverse trig functions to find what's the cosine of the same angle in quadrant 1 that has that. Well, it's approximately 0.827. What is square root of 33 over 7? No flipping clue. I'm hoping it's 0.8207. Otherwise, I made a mistake, which is not uncommon to make mistakes, right? So I'm just going to go square root of 33 over 7. Damn, that looks familiar. Now, you'll notice that using those two techniques, I'm off in the something like the 1/1000th place or something. It's like, no, that's basically the same number. So I've checked it on my calculator. That's how you can check your work. Show your work, check your answers. No more than one way to do a problem. Check your work, assuming you have time. Now, I would not take that much time to check my stuff on, say, an ACT test, right? I would mark it, I would do it, I would get my answer, I would move on, I'd put check later, and then I might pull out the calculator and check it later if I'm done and I still have 5 minutes left and I have some problems to check. But I wouldn't take an extra minute on problems on an ACT where you're looking to complete every problem in less than a minute. I wouldn't take an extra minute to check my crap. I just no, would not do that. So anyway, we know this answer is right. And the only way I would have gotten it wrong is if I had actually typed it wrong on my screen, because I checked my work here. All right. Use a calculator to find it. Cotangent of 2 pi over 13. Now, there isn't a cotangent button. And last time I looked for the secant and cosecant in those, they're not in the catalog either. You have to know how to use your calculator to find this. So we need to use a trig identity. In this case, it's going to be a reciprocal identity. Cotangent of 2 pi over 13, right? So I'm going to need a trig identity. Well, cotangent is 1 over tangent of 2 pi over 13. Okay, well, this is radians. My calculator's all defaults in radian mode. I'll reset it anyway. And then I'm just going to take the reciprocal. So that's what I'm going to do. All right. So I'm just going to reset my calculator. Second, mem, 7, 1, 2. My calculator's in radian mode. Yes. Right. And then I'm going to go tangent of 2 pi over 13. Done. Boom. That's not my final answer. That's about a half. So my answer is going to be a little less than 2. So now I just need the reciprocal of that, right? So I can go 1 over, and I can either arrow up and find it. The other one to do it is to go second minus, which is my previous answer, 1.9, right? So this is about 1.905. And if they want 2 decimal places, it's going to be 1.91. If they want 1, it's going to be 1.9. So new share. They want 4 decimal places. Of course, I stopped 1 too short. 5, 3, 1.9053. That's not what I needed. That's what I need. All right. So the answer is 1.9053. That's rounded to 4 decimal places. All right. So basically solve for a part of a right triangle. Those of you who are online can see this. My in-person people can't. So let me switch back to this here. Okay. So I'm going to just draw the sketch. This is 35 degrees. Now, the 2 triangles I know of that are near 30, I can use this for estimating, just for a big picture, right? I've got a 30 degrees. That's 1, 2, square root of 3, 30, 60, 90. And then the other one I know is 37 degrees-ish, 53 degrees. That's a 3, 4, 5 triangle. I know those ratios. Whichever ratio I find is going to be between these 2. And so it'll help me estimate and check whether my answer makes sense. Okay. So this would be 70. This is A, and that's 35 degrees. Okay. So the ratio that I'm looking for is opposite over adjacent. A over 70. That's tangent of 35 degrees, right? Interestingly enough, it's going to get bigger as it gets bigger here, right? So it's going to be bigger than 1 over the square root of 3, right? And it's going to be less than 3/4. This ratio, the 9 over 70. Okay. So give or take, it's going to be a little less than 3/4. Okay. A fourth of 60 would be 15. So 3 of those would be 45. So I'm thinking this is going to be like 45-ish, just in my head. This is the equation that I'm going to solve, right? So solving this, if I multiply both sides by 70, and you can even put the units, right? This is centimeters, I think. Centimeters, 70. So 70 centimeters times tangent of 35 degrees, right? So 70 centimeters times tangent of 35 degrees is A. Right? So now I can just put that in my calculator. Okay. So 70 tangent, my calculator's in radian mode. I almost never switch because I'm switching between degrees and radians on all of these problems. I don't want to get caught on the wrong place. So I'm going to do it this way. 35, oh, I need radians, degrees to radians, times pi, and you don't have to put times pi, you can just go 35 pi, you don't have to put times, over 180. And I let the calculator do the conversion for me. I don't even worry about it. I'm expecting an answer around 45. 49, I'll buy that answer. That's reasonably close given my knowledge of right triangles. The two most common ones that you're going to see are 30, 60, 90s and 3, 4, 5s. 45, 45, 90s have their uses, but are less useful, about 1.41 or 1 over 0.705. Or 0.707, I don't even remember. 49-ish, right? So this is 49.01. That's 2 decimal places is the most that they're going to want. I'm not sure what they're going to ask in the actual problem. Whole number, 49, done. Okay. All right, word problems. Plane rises from takeoff and flies at an angle of 6 degrees. When it has gained 650 feet, now this is not to scale. My angle is much bigger than 6 degrees. Okay. How far has the plane flown? In other words, what's C? And you notice they give you the letters, right? That's little a. This is a sine problem. Sine of 6 degrees is opposite 650 feet over C. Okay, so at this point, multiply by, actually, what I'm going to multiply by C, but I'm also going to divide by sine over 6 degrees. Whatever that number is, that's now 1, that's C. So C is equal to 650 feet over this thing, sine of 6 degrees. Now we're going to put it in the calculator. Again, I leave my calculator in radian mode, so I'm going to go 650 divided by sine 6. That's in degrees. I need radians, so I'll just go 6 pi over 180. Your mileage may vary. You're welcome to use switch to degree mode, work in degrees for degree problems, then reset your calculator or however you want to manage it. I just show you what I do, especially when you're looking at test taking, time sensitive test taking, where you don't want to switch modes and there's a lot of other things that can distract you. The easiest way for me to manage this, it's a little more typing on the keyboard, but it's easier for me to just leave my calculator in radian mode. Now, if I'm doing a whole host of problems that are all in degree mode, there are a few times where I will switch to degrees, but this ain't it. Especially a chapter like this, where we are doing degrees to radians, radians to degrees a lot. Okay, so this is going to probably be to the nearest foot. So this is C is about equal to 6218.40. That's probably, they want it probably rounded to the nearest foot. Round to the nearest foot. Yep, 6218. Evaluate, find the value of tangent of pi over 2 and or tell us that it's undefined, right? So tangent of pi over 2, tangent of 90 degrees. Okay, so I'm just going to draw a quick sketch. This is pi over 2, that's theta, that's 90 degrees. Tangent of pi over 2 is opposite, that's my y value, over hypotenuse, which is the radius. And if this is unit circle, right, this is the point 0, 1, this is r equals 1, this is 1 over 1, which is 1. Now, I can check this on my calculator. You should be able to do this by hand. However, I'm going to check it on my calculator. All right, so I'm just going to go tangent, because I can get distracted or misread a problem or something. I'm less likely to make the same exact mistake twice if I get. I did sine. I did sine. Sure as shooting. Tangent is opposite over adjacent. Tangent of pi over 2 is y over x, which is 1 over 0, which is undefined. Sure enough. So I distracted myself talking and I wrote tangent and I did the ratio for sine. Easy enough to do. Okay, I'm good at this. I've been doing trig for over 30 years. If I can make that mistake, you'll make it on next week unless you show your work, check your answers. I caught my mistake before I put it in. Okay, so the correct answer is undefined. Tangent of pi over 2. The other thing you could do is you could also just check your formula sheet, because your formula sheet has the table for tangent of pi over 2. It'll also tell you tangent of pi over 2 is undefined. But if you're looking at your formula sheet, you might look at the sine column instead of the tangent column. There's all kinds of ways you can distract yourself or do dumb crap. Don't do stupid. All right. Tell me where this angle lies. Tangent is negative. So tangent of theta is negative. Secant theta is negative. All right. So I want to know that quadrant. Secant is 1 over cosine theta, which means cosine theta is negative. Where is tangent and cosine negative? Well, that's here. All students take calculus. Tangent is negative in quadrants 4 and 2. Cosine's positive here. Cosine is negative. This is quadrant 2. That's what we're testing. On to the next one. Find the reference angle, negative 165 degrees, right? Boop. So there's 15 more degrees to get to 180, or negative 180 as it were. My reference angle, just where you see me drawing it, my reference angle, theta is negative 165 degrees. My reference angle phi is 15 degrees. And that's how I will use my trig tables, which work for acute angles between 0 and 90 degrees. 15 degrees is the angle that I'm going to use if I'm using a trig table. Okay, so my reference angle is 15 degrees. Or later on, like in next chapter, where we'll have the half angle formula, we'll be able to find the exact value for 15 degrees, because we found the reference angle, and then we could do we can use the sine and cosine of 30 degrees and use a half angle formula to get an exact value. Why do we do that? It's because we want to test and see how you understand trig and know how to use identities. It's not really practical. The real answer is, if you need a decimal approximation, put that shit in your calculator and get a decimal approximation. But again, part of this, you're in class, we're trying to improve your math foo, so that when you need to use this to solve more complicated problems, you can do it. In this case, my reference angle is 15 degrees. It gets used in a lot of other different things. The nice thing is, you're going through this, you notice you can watch a video about finding reference angles, drawing your angles in standard position and using terminal point on the side of the angle to find the trig values of any angle. So this stuff is in there. As you work through this stuff, feel free to watch the videos of the author doing this. Only 30 minutes into this, but we're doing pretty good. All right. use reference angles to find the exact value. All right. So cosine of negative pi over 3. I want the exact value. Now, let me just stop and share real quick. Cosine odd or even?
Cosine's even.
Cosine is even. So without drawing anything, this is the same as cosine of pi over 3. Since pi over 3 is less than 90 degrees, that is my reference angle, and the cosine of pi over 3 is the cosine of my 60 degrees, which is pi over 3, right? That's 1, that's 2, that's square root of 3. It's a half. Cosine of negative pi over 3, I can check that by plugging it into my calculator, and I will see that the cosine of negative pi over 3 is also a half, but I'm going to try to get through as much as I can here. So the correct answer is cosine is a half. Cosine is never undefined. Neither is sine. Sine and cosine are always defined. They create those nice, smooth sinusoids. It's the other 4 functions, which are reciprocals, that sometimes have 0 values for sine or cosine, which make your denominator 0. Cosine and sine are never undefined. So 1/2. That's the correct answer. There's other ways to do that, but here we go. All right, here we got a unit circle, and they've got some key points on the unit circle. Tangent of 2 pi. Tangent is opposite over adjacent. TOA. It's 0 over 1. Tangent of 2 pi is the same. By the way, it's periodic in pi. It's the same as tangent of 0. It's also the same as the tangent of pi. But either way, it's 0 as the y value. That's 0. You can check that on your calculator. It is defined, and we're moving on. All right. So now we're going to work with a little bit of algebra. Sine t, another name for that, we're just going to call it A. Cosine t is B, and tangent of t equals C. So 7 sine negative t minus sine t. All right. Now I'm going to work this. They're just trying to make sure you know how to do algebra with trig functions, right? Sine is odd, so this is negative 7 sine t minus sine t. Negative 7 apples minus 1 apple is negative 8 apples. Sine t, so negative 8 apples. They want you to get to here, but rather than writing it this way, this is how we'll work with it. You need to get used to working with trig functions and doing algebra like this. This is just one of the ways they test it. You can get it to here, and this is minus 8. Write it in terms of A, B, and C. Okay, so you need to know your trig functions. There's a whole realm of trying to define and model using trig functions and sums and differences and different frequencies of trig functions. It's called Fourier analysis. Okay, when you hear sound is made up of a bunch of frequencies, that sounds like trig functions, right? Oscillations, and there's different ones moving at different frequencies, high pitch, low pitch. Fourier analysis is one of the earliest and most useful forms of what we call transformations. Okay, signals processing, that sort of thing. It's a lot of applications, but anyway, this is an introduction to that idea. So the answer here is negative 8a. All right, what's my amplitude? The amplitude, my coefficient is 1. The amplitude is the absolute value of 1, which is 1. What's my period? 2 pi over 5, right? T equals 2 pi over omega, which is 5. 2 pi over 5. What's my frequency? 5 over 2 pi. Frequency is the reciprocal of period. You need to be able to find those things and use them to help graph. What's my period? Oh, they want the period, right? The period, T equals 2 pi over omega. It's 2 pi over 5. Boom. That's my period. And now I need to graph it. Boom. All right. So my amplitude is 1. My period is 2 pi over 5. It has no vertical shift. It has no horizontal shift. It doesn't have a reflection because my amplitude isn't negative. I don't have any of that good stuff. I don't have a negative inside the sign. So, I got to stop sharing this thing. It's plugging up my screen where I can't even click on what I need to. I apologize to the home gamers there, but I can save that and I'll check my answer and move on to the next problem. All right. So let's reshare. I apologize for not being able to show you all me finishing that out, but that's how we solved that. Okay. Amplitude and period, then graph. Okay. So y equals 6 cosine 4 pi x. A equals 6. Big A equals absolute value of A, absolute value of 6, which is 6. My amplitude is 6. Omega is 4 pi. It's a cosine function. Sinusoids have a period of 2 pi over omega. Tangent and cotangent are periodic in pi. So in this case, T equals 2 pi over omega, which is 2 pi over 4 pi, which is a half. Another way to check that really quick is if I plug in a half here, then what I end up with is 2 pi. I've gone from 0 to a half. I go from 0 to 2 pi inside the cosine. Yes, that's how periodic it should be. That's just a really quick check just to make sure you did it right. So my period is a half. My frequency is 2. I get 2 cycles if this is in seconds. If my period is my period is a half a second, then I get 2 cycles in 1 second. That makes sense. Okay. You ought to be able to draw these by hand, but rather than do that, I'm just going to use the so the amplitude is 6. The period is a half. Okay. And then to do my function, I want the sine tool. Boom. Amplitude of 6, which is going to make things taller. It's a vertical stretch. It distorts things. And then the period is a half. I have no reflections, no phase shift, nothing vertical, no vertical shift, no horizontal shift, none of that. Okay. That was stupid. I'm going to have to check it without you guys seeing it. Where the heck is my save? Done. Okay. Did something wrong. It's a cosine function. I used the sine tool. That was stupid. I would have gotten that wrong on the test because I graphed with a sine and this is a cosine function. So back to reshare. So I can either keep with the sine function and shift it to the left by a quarter of a period, which is 1/8, or I can use the cosine tool. In order to fix this one, I should have used the cosine tool, but because this is the sine tool, I can also phase shift this thing to the left 1/4 of a period, which is 1/8. That'll get me the right graph. You should have used the cosine tool and put in the amplitude and period and been done with it, right? But that's going to let me save that. That shifts it right. That gets me the cosine that I want, and I'm good. You can do either one, but if you do the wrong one, it's wrong. So show your work, check your answers. Mr. Miller would have gotten part of that problem wrong. Graph 2 periods of tangent, right? -2 tangent 1/3 x. All right. So first there's a negative, so it's going to have a reflection across the x-axis. Y positives become negative, negatives become positive. So that's important. It's got a vertical stretch by 2. What does tangent look like? Well, tangent is periodic in pi. Not there. Sorry. So it goes from pi over 2 to negative pi over 2. Tangent is odd, and it looks like this. That's what tangent looks like. And then this comes up and goes there. This looks like this. Okay. So there's three pieces of it. The key point that I track on is at pi over 4. This is at 1. So at negative pi over 4, that's at negative 1. So I want to track those 2 points. So I'm going to stretch by 2 and reflect, right? Oh yeah, I need to change the period. Here, omega equals 1/3. And for tangent, t equals pi over omega. This is pi over 1/3, which is 3 pi. So on my sketch, I don't have any horizontal phase shift. I don't have a vertical shift. There's no pluses or minuses. So when I draw my asymptotes, my period is 3 pi, half above, half below. So this is 3 pi over 2. 3 pi over 2. 0, 0 doesn't go anywhere. It reflects across the x-axis. And now this is at 2, right? And then this will be halfway there. So this will be 3 pi over 4. And this will be, sorry, that's negative. So it's 3 pi over 4. Okay. So now, and then I can then, anyway, that's 2 periods of that. So now I can find that sketch here, okay? B and C are definitely wrong. Okay. A looks like it could be right. And D looks like it could be right. And I just have to zoom in and see. D is stretched too much, right? Because when I get to 3 pi over 2, I'm like all the way up here at 9. It's just like, no. So A is my correct answer. Now I just have to get it where I can select A. D is stretched too much. It's only a stretch by 2. It's not a stretch by 3 or 9 or whatever. Okay. The good news is on that one, honestly, you know, if you're not sure, at least just knowing how reflections work and the basic shape of the tangent graph, you can narrow it down to 2. You know, it's like, okay, I got a 50-50 chance. Go with my gut. So there you go. Graph 2 periods of cotangent. Now, tangent is odd. Cotangent. Is cotangent even? I don't think it is. It is periodic in pi, though. The amplitude is 1/3. There's no reflection. Cotangent looks like this. Again, periodic in pi. That's the original one. There's cotangent. And then here, t equals pi over omega, which is 3. So now I'm just going to go pi over, it's going to be 2 pi over 3. And then my stretch, instead of here at 1, that's going to be a third. So it's going to be flatter. All right. So I'm looking for that. So it's either B or C. A is a throwaway. And so now when I come over to pi over 2, I should only go up to 1/3. Which is, this one goes up to like a half. Oh, it's also got, this has a vertical shift in it. B has a vertical shift. There's no vertical shift in this. So C is my only correct answer. C is the only one with even close to the right shape. Okay. You can also put these functions in your calculator and look at them on your calculator to check your work. Graph 2 periods of cosecant. Cosecant is the reciprocal of sine. So y equals 3 cosecant x. What I'm going to graph, right? If that's y1, I'm going to graph y2, 3 sine x. I'm going to graph the sine function, 3 sine of x. Well, that's periodic in 2 pi. 2 pi, there's pi, negative pi, pi over 2, 3 pi over 2. Right? Cosecant x equals 1 sine. So if I sketch sine, now 3 sine, right? So that's 3. Once you graph the sine thing, anytime sine is 0, 1 over 0 is undefined. So you can see my vertical asymptotes at each of these points, right? And then here, whoop, it's going to be these cups that look like that. Peaks and valleys. Okay. That's still the point. That's pi over 2 comma 3. That's the point where they're the same. Everywhere else, they're reciprocals of one another. Reciprocal of 1 is 1. So A, you notice the red graph is a cosine. Nope. B, the graph is a negative cosine. Nope. C, the graph is definitely sine. That's the red dashed one. D, the graph is negative sine. So the only one that actually works is C. You don't even have to worry about the amplitude. The only one that even has the right shape is C. Find the exact value. Cos inverse negative pi over 2 over 2. All right. I want the exact value. Cos inverse of negative pi over 2. Sorry, not pi over 2. Negative square root of 2 over 2. I want an exact value. Now I'm going to use my calculator to approximate this as well. Okay. But I want to draw this. Cosine inverse, right? These answers will always between 0 and 180 degrees. Between 0 and pi radians. That's what cosine inverse gives you. So I want to draw negative square root of 2 over 2 between 0 and 180 degrees. Well, cosine is negative over here, right? Right. And if this is 1, that's square root of 2. That's negative 1 cosine, right? This is cosine of negative 1 over the square root of 2. That angle is 135 degrees. It's 3 pi over 4. Cosine inverse says what angle gives that to me? 3 pi over 4. That's the exact value. Now, I can check that very quickly on my calculator, right? I can go 3, quit this. I can go 3 pi over 4. That's how many radians it should be. I can also go cos inverse of square root of 2, boom, over 2. This should give me the same answer in radians. I did something wrong. Oh, that's my, I should have put a negative in there, didn't I? I dropped the minus sign. I did a Miller. Cosine inverse. Cosine inverse. Second cosine inverse negative square root of 2. When I was checking my work, I did a Miller and dropped a minus sign. Boom. All right. So that lets me check my work. Yes, the correct answer, the exact answer is 3 pi over 4. If you type the decimal approximation, it's wrong. You use the decimal approximation to check your work. It is not the exact answer. You online did not see me do that. Sorry. I just typed it in my calculator. I apologize. I forgot to show that to you guys. If you guys can't see what I'm typing on my calculator online, you need to speak up. The answer is 3 pi over 4. Yeah. It's almost 9. How close are we to done with this thing here? 21. I got 5 more to do. 20 minutes might make it. Use a calculator to find the answer and round. That one's just plug it into your calculator. I'm not even going to cover that. Plug that in your calculator. Yep, that's a ratio. It's done. Okay. Tangent inverse of tangent of 3 pi over 4. Tangent inverse of tangent of 3 pi over 4. Okay. How do you do this? Well, order of operations. First, I need to figure out tangent of 3 pi over 4. Well, 3 pi over 4 is 135 degrees. So I'm over here in quadrant 2, right? There's pi over 4. My reference angle is 45 degrees. So I'm working with a 45, 45, 90, right? That's 1. That's square root of 2. Tangent of 3 pi over 4 is opposite over adjacent, right? It's 1 over -1, which is -1. So this is the same as saying tangent inverse of -1. Tangent inverse always gives answers between negative pi over 2 and pi over 2. That isn't in that range. Tangent inverse of tangent will not give me 3 pi over 4 back. What it's going to give me is this one, the one that's coterminal with negative pi over 4. That's the right answer. The right answer is this is negative pi over 4. Then if you put it in your calculator, you can check that. Solve. So get you used to using A, B, c, little a, little b. A equals 28.4. C equals 54.4. Okay. So the first thing is I can use the Pythagorean theorem, right? So c squared is a squared plus b squared. So 54.4 squared equals 28.4 squared plus b squared. So I can find b. These are all distances. This is all quadrant one. These are all positive. This is an acute right triangle. This is right triangle trig, so I don't have to worry about negatives in here. But regardless, I'm just going to plug that stuff in my calculator. Right, so 54.4 squared. So this is 2959.36 equals 28.4 squared. Boom. This is 806.56 plus b squared. Subtract 806.56 from both sides, 806.56. Now, rather than me typing it, I can just arrow up and I can say this minus that. So this is 2152.8 equals b squared. So b equals plus or minus. I'm going to ignore the negative. Square root 2152.8. And so now I can just go second square root of, and I'm just, instead of arrowing up, I'm going to go of my previous answer, 46. Right, so it's approximately 46 point, and they were at 1 decimal place. I'm going to put 2 decimal places, but that rounds up to 46.40. Okay, so that's B, 46.40. Now I need to find the other 2 angles. Couple of ways to do it. I'm going to start with, they gave me an opposite and a hypotenuse, right? So I can say that sine A equals 28.4 over 54.4. So A is going to be the inverse sine. Sine inverse gives me answers between negative pi over 2 and pi over 2, between negative 90 degrees and 90 degrees. So this will give me the right answer. It's going to give me an angle that's less than 90 degrees. It's positive. So sine inverse of 28.4 over 54.4. Right? And so I'm going to put that in my calculator. I'm going to get a certain number of degrees. And I'm going to show you how we can check our work with this in a couple of ways. Right. So 28.4 divided by 54.4. All right, it's a little more than a half. So my answer should be a little more than 30 degrees, because sine of 30 degrees is a half. Sine is an increasing function, so it should, my angle should be a little more than 30 degrees, like 32, 34, 35, something like that. Okay, so I'm going to do sine inverse of this. Boom. Now it's going to give me my answer in radians because my calculator's in radian mode. I need degrees, so I'm going to go times 180 degrees over pi. Your mileage may vary if you do this in you put your calculator. So 31.47. I'll buy that for $1. It's a little more than 30 degrees, which is what I was expecting. Okay, 31 A is about equal to 31.47 degrees. Now, I don't know how many they want us rounded to. To the nearest 10th. So 31.5 degrees. So this is going to be 31.5 degrees. Now, B is the co-angle, right? So I can do 90 degrees minus 31.5 to get B, which is what I'm going to do. Right? So I just go 90 minus, and I'm gonna round it here, 31.5, 58, a little less than 60 degrees, right? So B, this one is 31.5 degrees approximately, and this one is approximately 58.5 degrees. There's you can check it using some other trig ratios if you want, but I'm just going to move on with this one at this point. But that's solving the triangle. I gave you 2 pieces of information in a right triangle. You actually have 3 pieces of information because it's a right triangle. So you know one of the angles is 90 degrees. And so you have to then find the other 3 pieces of information, the other side and the other 2 angles in this case. So this is 58.5 degrees. And then B is approximately, they want the nearest 100th here. So 46.40, 46.40. Done. All right. Simple harmonic motion. Probably cosine. Yep. Cosine. Last one. Displacement is 3 cosine pi over 2 t. My amplitude is 3. Omega is pi over 2. T equals 2 pi over omega. It's 2 pi over 2, which is 2 pi over 1 times 2 over pi, which is 4. My period is 4. My frequency is 1/4. I go through 1/4 of a cycle per second if this is 4 seconds, if T is time in seconds. Right, so this is 4 seconds. This is 1/4 hertz cycles per second, if we're talking units. Okay. I didn't check the units on the other one, but anyway, inches. The units are in inches. So my amplitude is 3 inches. Yay. My frequency is 1/4 cycles per second. That's in hertz. My period is the reciprocal. It's 4 seconds. Okay. And our final question. A ramp is to be built by a campus library. The angle of elevation. Find the angle of elevation to the nearest 10th if the final height is 5 feet. Okay. So I've got steps and then I want a ramp. It's going to be 22 feet long. Okay. The final height is 5 feet. I want to know theta, the angle of elevation. Okay. In other words, sine theta, opposite over hypotenuse. is 5 feet over 22 feet. Right? It's 5 over 22. So theta, because this is a right angle, is going to be the sine inverse of 5 over 22. I'm going to want my answer in degrees, but into my calculator. Sine inverse 5 over 22. Boom. That's 0.2993 times 180 degrees over pi. I want my angle in degrees. 0.22. Yeah, it doesn't matter because I'm not going to type it anyway. I'm just going to do the, it does help to write. I don't want to write untrue things, but I'm just going to use that information anyway. So I'm just going to go times 180 degrees. Thank you for correcting me. Over 13 degrees. And that sounds about right. That's ballpark. 13.1 degrees, maybe tenths of a degree. I don't even know what they're looking for there, but let me pull this up. Tenths of a degree, 13.1. Boom, and we're done. All right. So there we go. I skipped one earlier. All right. So cosine inverse of negative 0.1, answer in radians, round to the nearest hundredth. So that's a just plug it in your calculator, right? So cosine inverse of negative 0.81, boom. Yes. Cosine is even, but 2.5149. How many decimal places do they want this from? So cosine inverse of negative 0.81 is approximately equal to 2.514948. And then now I have a rounding problem. Nearest hundredth, so 2.51 in radians. Done. Okay. All right, that's it. That's every problem on there and done in less than an hour and 20 minutes. Okay. You'll have at least 2 hours to do your test. We won't have a full 2 hours in class. I'll try to be here early on Thursday. So those of you who want to start can get started early. The normal time for the stream shows up at 7:50. So I'll try to be here at 7:45. So those who are physically here in class can ask. If you're at home, you're welcome to log in and just check in that way, even if you're doing the test at home. In case you have questions, you can ask questions. I will certainly answer questions about the homework or anything else on Thursday before the test starts. So if you have them, send it to me. Between now and then, we have student hours from 10 to 11 today. So in a little under an hour. Tonight from 7:30 to 8:30. Tomorrow night from 7:30 to 8:30. So there's 2 evening student hours between now and then. I'll be in my office tomorrow, so available off and on. Thursday, we've got our test, so see you then, and then enjoy your weekend after having passed your first trig test with hopefully an A. Calculus, we got calculus next fall, guys. So for those of you all who are going to be with Pamlico next fall, there is a follow-on to this class. You do not have to go to Craven to take calculus next fall. You can take it here, so that'll be good. So if any of you all are interested in that, let me know. We'll start registering for the fall in mid-March. So I want to get as many people registered early so they don't cancel it. As long as we have like even 1 or 2 people in the class, the school's probably going to offer it the first semester. Whether they keep offering it after that depends on if we can get, something like 4 or 5 people in a calculus class. But I'm reasonably confident. I'm more than 90% confident we'll be doing calculus next fall. If something changes between now and then and you have to go to Craven or someplace else, we'll let you know well before the semester so that you can get, if you do have to go to Craven, you might have to start with a regular class at the regular time. We won't leave you waiting right up until the end. So, all right. Thank you so much. I'm going to shut her down and call it a day. Have a good one. Thanks for joining me, everybody. I'll stay here in case anyone's got questions. I'm going to stop the recording.